Now we have to do momentum, very important topic. Momentum, we represent momentum with P. Now first of all we have to do the definition. So the definition of momentum is defined as, it is the definition, this is the definition, it is the product of mass and velocity. So momentum P is equal to mass m multiplied by velocity v. So P is equal to mv. SI unit, it is a vector quantity. SI unit is kilogram meter per second or Newton second. Now the next part is that change in velocity. Change in velocity, delta v. So whenever you find the change in velocity, you have to be careful about that. Suppose a ball of mass m, moving with initial velocity u, force apply on the ball, and as a result its velocity becomes v, the force we apply on the ball. So change in velocity delta v is equal to v minus u. Now what happens if ball bounce back? If body bounce back, if body bounce back, so we have a wall, this is our wall, this is my wall, and a ball is moving with velocity, initial velocity u. After collision with the wall, hit to the wall, it bounced back with velocity v. So change in velocity is equal to final velocity minus initial velocity. Final velocity v minus v minus u. Why we do the velocity minus v? Because y minus v, as velocity is vector quantity, so sign shows direction. Very important point, that note, to find change in velocity of body which bounce back we always add velocities. We add velocity of body. If body moves towards right, velocity is positive. If body moves towards left, velocity is negative. These all depend upon the convection sign. If you are taking the velocity towards right is negative and left, then left is positive. Now the next part is the change in momentum. Change in momentum. So change in momentum delta P. How to find the change in momentum delta P? Delta P is equal to final momentum minus initial momentum. Final momentum mass multiplied by velocity minus initial momentum, where PF final momentum, PI initial momentum, V final velocity, U initial velocity, delta P change in momentum. So delta P is equal to mv minus u. If body bounce back, change in momentum if body bounce back, momentum is always added. So we have this wall, a ball of mass m, initial velocity ua, hit the wall, v. So delta p is equal to minus mv minus mu. So minus final momentum plus initial momentum. Negative sign shows final direction of momentum. Now the next is force. How we define force? Definition: rate of change of momentum, or change in momentum per unit time. Per unit time. SI unit Newton, vector quantity. Force is equal to delta P divided by T, where F is equal to force or resultant force. Delta P is equal to change in momentum. T is equal to time derivation. F is equal to delta P T. As F is equal to MA, A is equal to V minus U divided by T. So F is equal to M V minus U divided by T. So F is equal to MV minus MU divided by T. Delta P is equal to MV minus MU. So F is equal to delta P divided by T. Proof. Newton's second law of motion. Second law of motion. Resultant force is directly proportional to the rate of change of momentum. Impulse. It is the product of force and time for which force applied on the object. I is equal to F multiplied by T. I is equal to impulse. F is equal to force or resultant force. T is equal to time for which force acts on body. SI unit Newton second or kilogram meter per second. Show that impulse is equal to change in momentum. Impulse is equal to force multiplied by T, as F is equal to ma. So I is equal to mat, as A is equal to V minus U divided by T. So I is equal to m V minus U divided by T multiplied by T. I is equal to m V minus U T divided by T. T cancel. I is equal to m V minus mu. Delta P is equal to mv minus mu. So I is equal to delta P. Proof. Area under force time graph is equal to pulse. Force area under graph is equal to force multiplied by time is equal to impulse. Okay. Law of conservation of momentum. Law of conservation of momentum. For an isolated system of interacting bodies, total momentum, sum of total momentum before and after interaction remains conserved. So we have system of two bodies, a ball of mass ma, velocity, initial velocity ua, another ball of mass mb, velocity ub, is traveling both in opposite direction. They interact with each other, collide with each other. ma, mb. ma is traveling to the right, ma is traveling to the left with velocity va, and mb move to the right with the velocity vb. So sum of total momentum before interaction is equal to sum of total momentum after interaction. So ma ua plus mb minus ub, because body is moving to the left, so we have to use negative sign due to the vector. ma minus va, mb vb. So careful about the signs. Now we have reasoning question: why car has crumple zones? As the car hits, as the car collides, crumple zone crushes, deform or squeeze, force acts on body longer time, as f is equal to delta p by t. So the rate of change of momentum decreases, hence force on car and passenger in the car also decreases. So less injury causes. How airbag protect with how airbag avoid serious head injury. during accident. As the head hit to the inflated airbag, bag start to compresses. Head in contact with the bag for longer period of time. As force as F is equal to delta P by T, so rate of change of momentum decreases. So airbag exert less force on head. Assalamu alaikum.